Welcome to the era of artificial intelligence. Behind every stunning image generated by Midjourney, every intelligent response from ChatGPT, and every self-driving maneuver by a Tesla, there is a physical engine making it possible. These are not your average computer processors. These are AI chips. Today, we go deep under the hood to understand the silicon revolution that is changing the world. To understand an AI chip, we first must understand why our standard computers struggle with AI. Meet the CPU, or Central Processing Unit. Think of a CPU as a world-class mathematician. It is incredibly smart and can solve almost any logical problem, but it works on one task at a time. This is called sequential processing. It's perfect for running an operating system or a word processor. But AI is a different beast entirely. AI models, specifically deep learning, rely on millions or even billions of simple arithmetic operations happening simultaneously. If the CPU is a lone mathematician, the GPU, or graphics processing unit, is like a stadium filled with thousands of students doing basic addition and multiplication at the same time. This is parallel processing. Originally designed to render pixels for video games, GPUs found their true calling in AI because calculating a pixel is mathematically very similar to calculating a neural network's weight. But why did we move beyond GPUs? Enter the specialized AI chip, often called an AI accelerator or NPU, neural processing unit. Unlike a GPU, which is still somewhat flexible, an AI chip is hardwired for one thing: matrix multiplication. In AI, everything is a matrix. Your prompt is converted into numbers, arranged in grids, and multiplied against other grids of numbers called weights. Modern chips like the NVIDIA H100 or Google's TPU are designed to move these massive grids of data with zero friction. Let's talk about the memory wall. One of the biggest bottlenecks in AI isn't just how fast you can calculate, but how fast you can move data from memory to the processor. This is why AI chips use HBM, or high bandwidth memory. Instead of having memory sticks far away on the motherboard, HBM stacks memory layers directly on top of or right next to the processor using a technology called CoWoS, chip on wafer on substrate. This creates a massive data highway that prevents the processor from sitting idle. There are two main stages in AI: training and inference. Training is like teaching a student. It requires massive power, months of time, and trillions of data points. This is where giants like the NVIDIA H100 dominate. Inference is when the trained model answers your question. Inference chips need to be fast and energy efficient. This is why your smartphone has a small neural engine. It's a tiny AI chip optimized to recognize your face or enhance your photos without draining your battery. Not all AI chips are created equal. We have ASICs, or application-specific integrated circuits. These are chips designed for one specific AI task, like Google's Tensor Processing Unit, TPU. Because they don't have to worry about being general purpose, they are incredibly efficient. Then we have the giants of the industry: NVIDIA, which currently holds over 80% of the market share, followed by AMD with their MI300 series, and cloud giants like Amazon and Microsoft, who are now building their own custom silicon to save costs. The manufacturing of these chips is a geopolitical masterpiece. Almost all the world's most advanced AI chips are designed by companies like NVIDIA or Apple, but they are physically manufactured by one company, TSMC in Taiwan. Using extreme ultraviolet lithography, EUV, they etch transistors so small that they are measured in nanometers, roughly the size of a human DNA strand. A single H100 chip contains 80 billion transistors. As we look to the future, the challenge is sustainability. A single AI training run can consume as much electricity as hundreds of homes do in a year. The next frontier involves neuromorphic computing, chips that mimic the human brain's architecture, and optical computing, using light instead of electricity to move data. AI chips are the digital oil of the 21st century, and whoever controls the silicon controls the future of intelligence.